Okay, so imagine this for a second. You're the CIO of a massive $3 billion logistics firm.
Right.
You have all the resources in the world. You've got the best talent, the best tech, and, you want to be on the cutting edge.
Of course.
So you go out and you spend a fortune deploying, say, 12 different state-of-the-art AI agents. You're expecting this super intelligent fleet, right?
Yeah.
A hive mind.
That's a dream.
That is the dream. But instead, what you actually have, and this is a direct quote from one of our sources today, is 12 goldfish in 12 separate bowls.
That is just such a devastating image. It's funny, but it's also incredibly expensive humor.
It really stuck with me. 12 goldfish, just swimming around in their little bowls, completely unaware that the others even exist. The fraud detection tool doesn't talk to supply chain data. The pricing bot has no clue that customers are screaming in the support tickets. It is, like the source says, just organized chaos.
And that chaos, it actually has a name in the industry now. People are starting to call it enterprise amnesia.
Enterprise amnesia. I love that term, but I also kind of hate what it implies.
Yeah.
It sounds like we're spending huge amounts of money to build systems that basically have dementia.
That is precisely what's happening. And when you look at the numbers, it's actually frightening. We're seeing companies spend, upwards of $500,000 per use case?
Per use case.
Yeah, they build these brilliant singular tools, a smart chatbot here, a smart analyzer there. But because there's no connective tissue, no shared memory, the organization as a whole it acts like it has amnesia. It's a silent crisis.
So today, that's our mission.
Yeah.
We're going to move beyond the buzzwords. We're not talking about chatbots or assistants. We're going to talk about building an AI brainstem.
Right. Or what's technically known as a context graph. We're going to look at the architecture of this nervous system, the actual ROI, because the numbers are honestly staggering. And we're even going to get into how this all connects to physical reality, to hardware and firmware.
And we've got some fascinating stuff from MIT later on about how we interact with these systems, a whole new way of prompting that really changes the game.
Yeah, that part is great.
But let's start with that crisis, the silent crisis. The source material talks about this point solution paradox. Can you unpack that for us? Why is buying more smart tools making us stupider?
It really comes down to data sovereignty. The point solution paradox is this idea that every time you build or buy a smart tool, that tool, it reinvents its own data pipeline. It creates its own little world.
That builds a silo.
It's worse than a silo.
Yeah.
The source uses this fantastic analogy of a factory floor. Imagine you have 12 brilliant robots.
Okay.
They're welding perfectly. Their precision is just, unmatched. But they aren't sharing the same blueprint. So Robot A is welding a chassis and Robot B is building a frame.
But they're not talking to each other.
Exactly.
Yeah.
So Robot A builds a chassis that's maybe 2 millimeters too wide for the frame Robot B just finished. Both robots perform their individual tasks perfectly. You look at their metrics, they're all green. But the result is a car that either falls apart or can't even be assembled in the first place.
Because they lacked that shared context.
Precisely. And in a digital sense, that means you have data silos that cannot crosstalk. And when silos can't crosstalk, you just bleed cash.
Right.
You might have the smartest pricing algorithm in the world, optimizing for margin every millisecond. But if it doesn't know that your inventory is stuck in a storm in the Pacific, which your logistics bot does know, then your pricing is simply wrong, period.
So the pricing bot is busy selling phantom inventory at a premium, while the customer service bot is getting screamed at by angry clients.
And the marketing bot is probably sending them a discount coupon at the exact same time. It's just madness.
So the solution proposed here isn't just buy better AI, it's about structure. The source introduces this concept of the context graph. Now, to me, graph sounds like a chart, but this seems to be something much more alive. How is this different from just a really big database?
Oh, it's way more dynamic than a database. A database stores rows and columns. It stores data. A context graph stores relationships.
Right.
Think of the context graph not as a tool, but as the central nervous system of the enterprise. It's a living map. It maps customers, assets, contracts, events, and it sits on top of everything else. Your CRM, your ERP, your logs, your support tickets.
So it's the layer that connects all the dots.
It's the layer that holds the context. It doesn't just know that customer X exists. It understands that customer X signed contract Y, which is currently affected by shipping delays Z.
I see.
The shift here, and the source calls it the 2026 mandate, is to just stop building isolated agents. The goal is to ban any new AI project that doesn't read from and write to this shared context layer.
That's a bold mandate. Ban any project that doesn't connect. But when you look at the numbers and the deeper analysis, you start to see why.
Yeah, you do.
We have some tangible ROI figures here that are honestly pretty shocking. Let's run through them because I think this is where the rubber meets the road.
Let's do it. These are the aha moments for any CFO.
First up, fraud detection. So usually a fraud tool looks at payment patterns, right? Is this credit card from a weird location? That kind of thing.
Right, that's the standard approach. But in this new model, the fraud detection system sees the contract terms plus the delivery logs.
Okay.
By connecting those two previously separate worlds, the source notes it can stop $2 million a year in false claims.
$2 million. Just by letting the payment system see the delivery truck's GPS log.
Exactly. I mean, think about it. A customer claims item not received. A siloed fraud bot might just approve the refund to keep them happy.
Sure.
But the context graph sees that the GPS on the delivery truck was at their loading dock for 40 minutes, and the manifest was signed. It knows the claim is probably false.
That is incredible. It changes the game from just guessing to actually knowing.
Right.
Then there's renewals. This one seemed like low-hanging fruit, but apparently most companies miss it.
This is huge, especially for SaaS companies. By accessing usage data plus support tickets, the system retains 15% more customers.
Wow.
Because it knows not to try and upsell someone who's been complaining about a bug for the last 3 weeks.
That's the goldfish thing again, right? If you're a goldfish, you don't remember the complaint, so you call up and ask for more money, which is just insulting.
It's a churn trigger. But if you have a context graph, the system flags the account. Do not sell. Flag for executive support review. You save the relationship instead of destroying it.
And the third one is pricing. By reading inventory levels plus competitor moves in real time.
In real time, yeah.
The system boosted margins by 8% without losing market share. It's just compounding value.
It's not just smarter, it's more aware. It's capturing these fleeting opportunities. If a competitor runs out of stock and you know you have inventory, you can nudge your price up. But you can only do that if the pricing brain talks to the inventory brain.
It's fascinating because we often think of this context as purely digital, data on a screen. But one of our sources took us to Bengaluru, to a story about an EV startup, to show that context is also physical.
I love this story. It's such a perfect example of why software people need to understand hardware.
So, set the scene. You have a top-tier firmware developer. Their code is clean, it's efficient. They're building the operating system for a new electric vehicle.
Right. And on paper, everything looks perfect. The goal is to manage the car's sleep and wake cycles to conserve energy. It's supposed to last 8 hours on standby.
But when they actually test it, the battery's dying in 2 hours.
2 hours, a total disaster.
And then usually you'd blame the battery or you'd blame the code. You'd think, oh, there's a memory leak or the algorithm is inefficient.
Exactly. The team is baffled. They dig through the code. Nothing. It's pristine. They check the battery specs. It's functioning perfectly. They are just pulling their hair out.
So where do they find the answer? This is the part that feels like a detective novel.
They start looking at the dash cam logs. Not the code, but the actual video footage from inside the parked cars.
And this is the twist. What do they see?
They noticed a pattern. The car system kept registering that a door was opening and closing. Over and over and over, open, close, open, close.
The ghost in the machine.
More like a ghost in the plastic. It wasn't the code. It was a tiny, substandard plastic lever in the door mechanism.
Oh, way.
It was cracking under the physical stress of the car, just sitting there and moving slightly. Every time it cracked or shifted just a millimeter, it caused the sensor to misfire.
So the sensor screams, wake up! Someone's getting in.
Precisely. The computer wakes up, primes the dashboard, turns on the lights. Then the sensor settles, so it goes back to sleep. You repeat that 1,000 times a night.
And it drains the battery like a sieve.
That's it.
That is just wild. So the firmware was doing exactly what it was told to do. If door opens, wake up. But because the physical hardware was flawed, the software failed.
And that's the takeaway. Solid firmware needs solid foundations. You cannot have a smart system if you ignore the unsexy hardware details. And to bring it back to our topic, a true context graph needs to understand physical inputs too.
Right.
If the AI context included sensor reliability data or material stress limits, it might have flagged that lever issue much sooner.
It really reinforces that you can't just code your way out of physical reality.
Right.
Which actually, that segues perfectly into our next topic, this philosophy of the quiet architect.
This is a beautiful concept. We're so used to technology that just screams for attention. Disruption, revolution.
Yeah.
But the source argues that real technology doesn't just disrupt, it restores.
There's this really moving anecdote about a robot built not for headlines but to handle grenades so a worker could go home safe.
I'm safe tonight. That was the message that mattered. Not the stock price, not the tech blog write-up, the safety. It restored order.
And speaking of not chasing headlines, the source points out that the real money in AI isn't where everyone is looking.
Not at all.
Everyone is looking at chatbots and generative text. But the smart money, it's in garbage.
Literally. Waste management.
The example given is AMP Robotics. They used computer vision to sort recyclables.
And they raised $91 million doing it because they didn't ask, what cool AI can I build? They asked, what massive, unsexy industry is drowning in inefficiency?
It's the difference between building a toy and solving a real problem. Sorting recycling is dangerous, dirty, and slow for humans. For a robot with computer vision, it's just data.
And that is a lesson for everyone listening. Don't look for the shiny object. Look for the boredom. Look for the inefficiency. Look for the places where people are doing dangerous or repetitive work that hasn't changed in 50 years. That is where quiet impact happens.
I love that. Quiet impact. But let's shift gears from robots to humans, because even with all this automation, the human element is actually getting an upgrade, not a downgrade.
Yes. The future of work isn't about the lone genius anymore. The source makes a really strong case that the era of the solo inventor is fading.
They cite an MIT study that's just fascinating. It found that AI helps diverse teams surface the best ideas 70% faster.
70%. That is a massive jump in efficiency. But here is the key word: diverse.
Why does diversity matter more here?
Because AI acts as a synthesizer. In the past, maybe the loudest voice in the room won, or the person with the best English or the best slide deck.
Right.
The AI strips a lot of that away. It focuses on the merit of the idea itself. It allows the team to act like a Renaissance workshop.
That workshop comparison is great. We think of Michelangelo as a solo genius, but he ran a studio.
Exactly. It was a collaborative engine. AI allows us to return to that. It handles the root work, the structuring, so humans can focus on the creative direction. But, and this is a big but, you have to know how to talk to it.
This brings us to recursive metacognition. Now that sounds like a mouthful of academic jargon. What does it mean in plain English?
It does sound complex, yeah, but it's actually a very practical way to make the AI think more like a careful human team. Standard prompting is usually ask a question, get an answer.
Right. Write me an email. Here's the email. Simple.
Exactly. But recursive metacognition forces the model to level up. It's a prompting technique from MIT. Instead of just answering, the model has to do 3 specific things. First, break the problem into parts.
Okay. Deconstruct it. Don't just solve it. Show your work.
Second, check its own answers from multiple perspectives. Argue with itself, essentially. Why might I be wrong about this?
That's powerful. And third,
it has to score its own confidence. I am 90% sure about this fact, but only 40% sure about this conclusion.
So it's turning the AI from a yes man into a whole panel of experts.
That's it. And the result, a 110% improvement in performance on complex reasoning tasks. It turns a flat answer into a reasoned strategy.
That is something our listeners can try today. Next time you prompt, don't just ask for the output. Ask the AI to critique its own output before giving it to you.
Ask it to be its own devil's advocate. It changes everything.
Now, we have to talk about the elephant in the room. We've talked about connecting all the data, the context graph. We've talked about physical sensors. We've talked about AI teams accessing it all. If everything is connected, isn't that a security nightmare?
If you are using old school security, yes, an absolute nightmare.
The source calls VPNs, virtual private networks, a security blanket you've outgrown.
That's a harsh but very accurate assessment. The old model was castle and moat. Once you're inside the VPN, you're trusted. You're inside the castle walls. You can just roam the halls.
But if a hacker gets inside those walls,
they have the keys to the entire kingdom. And with the context graph, that kingdom is fully interconnected. If they get in, they can touch pricing, customer data, the physical controls of the warehouse robots. The blast radius is total.
So the security paradigm has to shift to something called zero trust.
Zero trust. And it sounds paranoid because, well, it is. The philosophy is never trust, always verify.
And how does that work practically?
No.
I don't want to type my password every single time I click my mouse.
It's not about passwords. It's about behavioral identity. The system constantly monitors context.
Give me an example.
Okay, let's say you log in from New York at 9:00 a.m. You access your usual marketing folders. The system says, okay, This looks like you.
Standard morning.
But then, at 11:00 a.m., your same credentials try to access the engineering source code, which you never touch. And the request is coming from an IP address in Shanghai.
Unless they have a teleporter, that's physically impossible.
Exactly. A traditional VPN might just see valid credentials and let them in. It says, the password is right, come on in.
Right.
A zero trust system says, the context is wrong, this behavior is impossible. Block access immediately.
So it's not just checking your ID at the front door. It's checking your ID every time you touch a doorknob inside the house.
Basically. And the stats here are worrying. 81% of organizations plan to adopt zero trust, but 79% will fail.
Why will they fail? That's a massive failure rate.
Because they treat it as a feature. Oh, let's just buy a zero trust tool and switch it on. But it's not a tool, it's an architecture. It requires rebuilding how your systems talk to each other. If you just slap a new lock on a broken door, you're not secure.
It comes back to that quiet architect idea. You have to build the system right from the ground up. You can't just paint over the rot.
Precisely. Connection is the intelligence, but connection without architecture is just vulnerability.
So we've covered a lot. From goldfish to brainstems, from broken levers and EVs to sorting garbage, and finally to the security of it all. If I'm a leader listening to this, what do I do? What is the Monday morning action plan?
The source lays out a very specific 2026 mandate. It's an execution blueprint, and it starts with ruthless focus.
Let's hear it. Step 1.
Step 1, pick 2 decision domains. Just 2. Don't try to boil the ocean. Pick 2 things that should talk to each other, but don't. Like, say, customer credit and inventory replenishment.
Okay, credit and inventory. 2 clear areas that usually live in different buildings.
Step 2, mandate that any new AI project must read and write to a shared context layer between those 2 domains.
No more silos. No more lonely goldfish.
And step 3, and this is the kicker, prove interoperability in 48 hours.
48 hours. That sounds impossible for a big company.
It sounds impossible because we're used to complexity.
Right.
But if the new tool can't talk to the existing graph within 2 days, it's too complex. It forces simplicity. If you can't get the data flowing in 48 hours, kill the pilot.
Wow. That is fast. But I guess speed is essential when you're trying to stop the bleeding.
Speed of connection, not just speed of deployment. That's the key.
It really changes the definition of profit, doesn't it? One of our sources had this profound line. Profit isn't a line on a statement. It's a system you design.
That is the core philosophy here. Whether it's the EV firmware, the recycling robot, or the enterprise data graph, you are designing a system. If you design it with amnesia, you lose. If you design it with context, if you let the pricing brain talk to the inventory brain, you win.
And as we look toward the future, specifically this future of work,
the most important degree is now in collaboration. That's a beautiful way to put it. It's not about what you know in isolation. It's about what you can connect.
it really is. So we want to leave you with a question to chew on, something to take back to your team, or just to think about on your commute.
It's a simple question, but if you answer it honestly, it might just change your entire roadmap.
What 3 decisions would transform if your AI remembered everything?
Not just the last email. Everything. The hardware, the logistics, the customer history.
Think about that. If your pricing knew your inventory, if your support knew your sales, if your firmware knew your hardware, what 3 decisions would change?
That's the difference between organized chaos and an AI brainstem.
Thanks for diving in with us today. Until next time, keep connecting the dots.